To make the search for life beyond our planet more organized and focused, scientists have come up with a metric known as the Earth Similarity Index. This metric evaluates how similar a planet or moon is to Earth based on different factors like temperature, atmospheric pressure, and habitability. The scale ranges from 0.0 to 1.0, where values between 0.8 and 1.0 indicate that a planet closely resembles Earth in various aspects. In recent years, technological advancements have allowed us to discover numerous exoplanets and moons that exhibit striking similarities to Earth. One such discovery occurred in 2019 with a planet called THRASH. It's classified as a super-Earth and orbits an M-type star every 4.9 days at a distance of 0.0252 astronomical units, AU. The THRASH star is one of the closest stars to our solar system, located approximately 12.4 light-years away from us. Despite being significantly less massive than our Sun and having a temperature of around 2,700 degrees Celsius, this red dwarf star can still provide sufficient heat for its two planets. Both of these exoplanets resemble the inner planets in our solar system and are only slightly more massive than Earth. They are situated in the habitable zone, where conditions may support liquid water. Among the two, THRASH stands out as the most promising. It has an Earth Similarity Index score of 0.95, making it the most Earth-like planet found so far. There's a 60% probability that this exoplanet maintains a surface environment with temperatures ranging from 0 to 50 degrees Celsius. If its atmosphere is similar to Earth's, the surface temperature would likely be around 28 degrees Celsius. THRASH, on the other hand, is farther from its star and has an Earth Similarity Index score of 0.68. It only has a 3% chance of having a warm surface temperature. If this world's atmosphere resembles that of Mars, its estimated temperatures would be around -47 degrees Celsius. Researchers are uncertain about the atmospheres of these two planets, but a thin atmosphere could distribute heat and cold across their tidally locked dark and light sides. Scientists suggest that atmospheres with densities between 1.3 to 17 times that of Earth could allow for the presence of liquid water on the surface. Moreover, there's another planetary system with some of the most promising candidates for extraterrestrial life, and a recent discovery in this system has just been announced. The TOI 700 planetary system is known to have at least 4 planets, 2 of which reside within the star's habitable zone. The most promising candidates in this system are TOI 700e and TOI 700d. Both are rocky planets with masses similar to Earth. TOI 700e has an orbital period of 28 days and is 95% the size of Earth, while TOI 700d has an orbital period of 37 days and is 105% the size of Earth. The TOI 700 system is quite ancient, with a history spanning over 1.5 billion years. This long time frame provides ample opportunity for biological activity to emerge and transform the region, where a planet's surface meets its atmosphere into a diverse biosphere. If TOI 700e and TOI 700d possess atmospheres, they could be significantly warmer than Earth's average temperature, which could be a game-changer in terms of their potential habitability. Scientists suspect that there may be more planets beyond TOI 700d, and if we were to one day discover life on any of these worlds, we would hope that it bears some resemblance to life on Earth. But is it theoretically possible for similar life forms to exist on other planets? Evolution is considered a fundamental principle of nature, much like gravity. Because of this, the principles of evolution that we've observed on Earth can be applied to other planets. This is due to a process called evolutionary convergence, where unrelated species can independently evolve similar adaptations in response to similar environmental challenges. The starting point for life on any alien planet must be simple, and on many of these worlds, it may have remained relatively basic. However, if some of these planets develop complex life forms, it could only have happened if beneficial changes were preserved and harmful ones were discarded. An illustrative example of this is the evolution of flight, which has occurred multiple times on Earth through the development of wings. In an environment with a fluid, like water, an organism can either float if it's lighter than the fluid, or use wings to generate lift and fly aerodynamically. The wings of bats, birds, and insects all serve the same purpose, but have evolved independently of each other. Similarly, if two exoplanets have identical conditions, such as temperature, atmospheric pressure, and access to water, it's possible that life could emerge on both planets and evolve in similar ways to adapt to their respective environments. Furthermore, the presence of similar conditions on exoplanets could lead to the development of similar biochemistry. Life on Earth is carbon-based, and it's plausible that life on exoplanets could also be carbon-based if their conditions resemble those on Earth. Therefore, if Teegarden B, Teegarden C, or TOI 700e were to support life, there's a high likelihood it could be carbon-based and at least somewhat similar to life on Earth. However, it's essential to remain open to the possibility of encountering life in the universe that takes on forms vastly different from what we know and understand. Even on Earth, we have extremophiles, organisms that can thrive in extremely harsh conditions that would be lethal to other life forms. These extremophiles serve as examples or models for potential unconventional life forms that might exist on other distant planets. While the search for alien life has predominantly focused on Earth-like planets, what if we were to shift our perspective and look for something completely different, a form of life as we don't know it? Perhaps a world with unusual life forms may possess a distinct and diverse set of planetary characteristics that differentiate it from more conventional planets. These characteristics might be necessary for the survival of extremophiles, which are life forms capable of thriving in extreme conditions, such as extreme temperatures, high levels of radiation, or high atmospheric pressure. Astronomers have recently discovered a new class of exoplanets known as Hycean planets. These planets are vastly different from Earth, but could potentially support life. Hycean planets are hot, ocean-covered worlds with hydrogen-rich atmospheres, which provide a larger habitable zone compared to Earth. This discovery opens the possibility of finding signs of life beyond our solar system in the coming years. Ocean planets can be up to 2.6 times larger than Earth and have atmospheric pressures reaching nearly 200 degrees Celsius. Despite these harsh conditions, their oceanic environments could potentially support microbial life similar to Earth's oceans. Hycean planets also come in various forms, such as dark Hycean worlds with potentially habitable conditions only on their night sides, and cold, icy Hycean worlds receiving little radiation from their stars. The surface pressure on such a planet would be similar to the depths of Earth's oceans where life still exists. This suggests that life could thrive under a heavy atmosphere on a high Hycean world. What's fascinating is that biomarkers, which are indicators of life, are easier to detect in the atmospheres of such planets due to their large size and higher temperatures compared to rocky exoplanets. Furthermore, a significant portion of the known exoplanet population, nearing about 5,300, meets the criteria to be classified as Hycean. One such intriguing world is called K218b, discovered in 2015 by NASA's Kepler spacecraft. K218b is located 124 light-years away in the constellation Leo and is considered a mini Neptune that orbits a dim red dwarf star. Researchers believe that planets like K218b could support life because they may have biomarker molecules like methyl chloride and dimethyl sulfide. Life forms on a Hycean planet would likely be based on hydrogen-based biochemistry, since hydrogen is the main component of such a planet's environment. This implies that organisms on these planets would have fundamentally different structures from carbon-based life forms, making them completely unknown to us. In fact, there's a possibility that we wouldn't even recognize life based on hydrogen biochemistry as living things. Astronomers are eagerly anticipating the opportunity to collect spectroscopic observations of Hycean planets, a class of planets with conditions potentially suitable for life. These planets are located relatively close to us, ranging from 35 to 150 light-years away. The James Webb Space Telescope already possesses the capability to examine their atmospheres, which hints at a series of mind-boggling discoveries in the near future. Expanding our perspective even further, we must question whether Earth is the optimal environment for life. While it clearly supports our existence, we've had ample time to adapt to our surroundings. What if there exists a planet elsewhere in the universe with even more favorable conditions for life? This concept is known as a superhabitable world and has already been explored within the scientific community. Superhabitable worlds would be older, slightly bigger, slightly warmer, and potentially more humid than Earth. Additionally, they would orbit stars that are older than our Sun and have longer lifespans. While our Sun is expected to last about 10 billion years, some stars can live longer, providing more time for life to evolve. To find these worlds, one idea is to look for planets around K-stars or orange-red dwarfs, which are cooler and less luminous than Sun-like stars, but have lifetimes ranging from 20 to 70 billion years. Life on a planet orbiting such a star would have more time to evolve and adapt. The ideal age for a planet would be around 5 to 8 billion years old, as going significantly older would mean the loss of interior geothermal heat and protective geomagnetic fields. Another characteristic of a superhabitable planet would be its size, which would be around 10% larger than Earth. This would provide more land area suitable for life. Making such an exoplanet 1.5 times as massive as Earth would provide a longer-lasting heat source from radioactive decay in its interior and stronger gravity to retain its atmosphere. Additionally, since there is more diversity of life in warmer and wetter regions, such as tropical rainforests on Earth, a superhabitable planet would need to have a mean surface temperature of about 5 degrees Celsius warmer than Earth. Scientists have formulated a recipe for the perfect planet, but the question remains, is it even possible for such a world to exist? Researchers have already identified approximately 24 candidate exoplanets that fit these criteria. In the near future, one of our telescopes could stumble across a planet that is well suited for humanity, and the search for alien life forms on a perfect new home for mankind continues. While we may never know what lies beyond the stars, it's exciting to contemplate the possibilities of what kind of world we would choose to call home.